How are you doing, math learners? This is your free access math teacher Ash, and welcome to ML with Sir Ash. We have already discussed about the overview on variations. So now we will talk about the first type of variation, and that is all about direct variations. So before going deeper to this topic, sit back, relax, and kindly click that subscribe button and notification bell for you to be updated of these cool clear math videos just like this. Hello math learners! Welcome to another session here in Math Learning with Sir Ash. Today, we're going to discuss the most essential learning competency-based lesson for Quarter 2 of the Grade 9 Mathematics, which is all about direct variations. Now, we have already talked about the overview on variations, the 4 different types. The first type is the direct variation. Now, what is this direct variation? Direct variation is the relationship of the change of two quantities in which one is affected directly proportional to the other quantity. Now, the mathematical statement that is denoted by this variation is y is equal to kx, where x and y are the variables or the quantities, and your k is the constant of variation. Now, the constant of variation is a fixed value. Now, how can we know that a certain situation is a direct variation? Now, let's consider an example in geometry. If you could consider the formula of the circle, C is equal to pi d, the circumference and the diameter. Now, if your diameter is like this, so the circle is just as little as this. When the diameter gets bigger, then your circle goes bigger also, right? That is an example of a direct variation. As your diameter increases, your circumference also increases. As your diameter decreases, your circumference also decreases. Now, consider this symbol, pi. Pi is denoted as 3.1416. This is an irrational number and this goes right. But we just use 3.14 as an approximation in solving our circumference. Now, this pi, regardless of how big or how small your diameter goes, that is constant. 3.1416 and so on and so forth, right? That is what we call a constant. So, this is just one scenario of how a direct variation is applied. Now, let's consider an example in which it is applied in the real world. Okay, math learners, we have here a certain example. A car travels 60 kilometers in an hour. If the speed doesn't change, how far does it travel for 2 hours? For 4 hours? Or for 30 minutes? Okay, so there are 3 problems that we need to know, right? The distance for 2 hours, the distance for 4 hours, and the distance it traveled for just 30 minutes. Okay, so as you can see, this is an example of a direct variation. Why? Because as the time increases, the distance also increases, right? Okay, so how do we solve this one? So let's consider our x is the time, and the distance is our y. Of course, the distance will depend on its time. So if there are more time, longer distance. If there are short time, shorter distance. Okay, so the solution is y is equal to kx. It was given that our distance is 60 kilometers if our time is 1 hour. Now, first thing you need to do here is to solve for your constant of variation. Okay, your k. So how do you solve for k? Basically, you just need to simplify this one. So k times 1, that is k, and you have 60. So therefore, your k is 60. Now, based on this scenario, if you have your value of your k, then you can make an equation out of this. So you have y is equal to kx. That is your overall equation for direct variation. But for this particular scenario, we can make an equation, and that is y is equal to 60x. Of course, we just need to change our time so that we can have our distance. Okay, so now let us solve for our first problem. So what is the distance traveled in 2 hours? So that is y is equal to 60 times 2 because our time here is 2. Okay, so we have y is equal to 120 kilometers. So therefore, for the first answer, we have 120 kilometers. So the same scenario, we just need to use this one, y is equal to 60x, and we will solve our 4 hours. So that is y is equal to 240 kilometers. Easy, right? And that is 240 kilometers. And finally, for our 30 minutes, remember that 30 minutes is 1/2 of an hour. Okay? So what we need to do is not to use the number 30, but instead use 1/2. Why 1/2? Because time here, or x here, is represented as time in hours. And 30 minutes is half an hour. Okay. So, that is 60 over 2, which is equal to 30 kilometers. Okay. So, you have now your 3 answers. Okay. And that is 30 kilometers. Easy, right? So, is there any other way to solve this problem? Well, there is, my dear math learners. That is by the use of proportion. Now, remember that y is equal to kx is our statement here, right? And this is stated as y varies directly as x. Remember with that statement, my dear math learners, because it is important for you to know the statement first, the relationship of the variables. So, for direct variation, the statement used normally is the varies directly or varies proportionally or is directly proportional or varies proportionally. Okay, so if this is the case, remember that k here can be solved by y divided by x. Okay, so therefore, in any other scenarios, my dear math learners, k can be solved y over x. K can be solved y over x. K can be solved y over x. Why am I writing this a lot of letters, my dear math learners? Remember, let's just consider the first given. Our y is 60 over 1. Our y here is 120 over 2. And here we have 240 over 4. So if you simplify each of the fractions, we have 60, 120 divided by 2, that is 60. 240 divided by 4, that is still 60. So basically, the constant is just the same, my dear math learners. Okay? The other way to solve this one is by the use of proportion. Now, if you want me to show you how it's done, basically it is this way. Now, let's say we don't know this one yet, right? So we have our proportion as 60 over 1. Okay? And then here, our time, this is y over x, right? So our time is 2 hours. And we don't know yet our y. Okay? So we just cross multiply the 2 given. And that is 60 times 2. So that is 120. Y times 1, that is y. So you already have your answer. And they are just the same here. Easy, right? So, that is how you get the solution in terms of certain problem. Now, let's try to consider whether how to solve this using just a mere statement. Okay, math learners, as you can see, we have here b varies directly as a. b is equal to 8 when a is equal to 24. What is b when a is equal to 6? Okay, I will show you 2 ways on how to solve this one. The first one is by the use of the variation statement. And since this is b varies directly as a, that is b is equal to ka, because it states that that is varies directly as a. Okay, so what we do here is that we substitute first 8 and 24. So we have 8 is equal to k times 24. Now, remember, my dear math learners, that you need to solve first for your k before going to the next situation. Okay, so by solving, we have 24k and the other side is 8. We divide both sides by 24 so that we can solve for k. And 8 over 24 is 1/3. Okay, this is not yet the answer for the problem, right? So, what we need to do now is to write our equation, and that is b and 1/3 a. So, we will now apply our second situation, that is b is equal to 1/3 times 6. And b, 1/3 of 6 is 6 times 1, that is 6, divided by 3, that is 2. So, b is 2. So, 24 becomes 6, 8 becomes 2. Easy, right? Now, what is the second way? You can just use the proportion. So, how do you use the proportion? So, that is basically the first set of ratio, that is b sub 1 divided by a sub 1 is equal to b sub 2 over a sub 2. So now, what we do here is, we just need to substitute. So our first b is 8, our first a is 24. Our second b is unknown, we don't know, that is x. And our second a is 6. So by just cross multiplication, we have 24x is equal to 48 because 6 times 8 is 48. We divide both sides by 24 and this will be cancelled. 48 divided by 24 is equal to 2. So the value of the other b, the second b, is equal to 2. Easy, right? So I hope you have learned something about how to solve for the k, how to solve for the other pair of the unknown in terms of the direct variation. Now, this is the time that I will challenge you whether you have understood our topic, and here it is. Okay, math learners, I hope you have a wonderful time about our topic for today. If you do have any questions and inquiries about our topic, do not hesitate to put your inquiries in our comment section below. I hope you can also show this or share this video to your classmates, schoolmates, and other students that you care for. This is still your free access math teacher, Ash, and always remember, it is fun to learn mathematics if we are together learning. Thank you so much, God bless, and hopefully, you do subscribe after watching this. Congratulations, math learners, for arriving to this part of the video. If you think that this video have helped you, click that like button. And if you think that this channel can change the way you see mathematics, do not forget to click that subscribe button and notification bell. Thank you.